Box plots, also known as box and whisker plots, are a way of visually graphing a 5-figure summary. We did this example in the last video, so we'll very quickly get the 5-figure summary. There's our median and Q1, 5.5 there for Q3. So this was our result of a 5-figure summary. We discovered that 18 was an outlier. If you're asked to do a box plot, you would do a 5-figure summary. We've done this already, but here it is, so I don't have to explain it again. So our 5-figure summary for this one was 1, 2, 4, 5.5, and the maximum is 18, but it is an outlier. So a box plot starts with a number line that's large enough to display all the data. You don't have to go up by ones, you can go up by twos, and since 18 centimeters won't fit on this, I'm going to go up by 2. So leave yourself at least 3 grid squares above your number line, more if you're doing 2 box plots on the same number line. Draw yourself a number line big enough to fit, and make sure you've got even gradations, as you always would, of course, with a number line. It is a good idea to go a little bit outside of the range that you need. So I need 1 to 18. I've gone 0 to 20. Now, you will have a space, and the idea is that a box indicates where the middle half of your data is, from Q1 up to Q3, with the median marked. That box should be 2 grid squares high. So my box here should go from 2 up to 5.5. It's going to be a little tricky there. There's 5, 5.5. Use your ruler to close off the box. And a line goes at the median, which is 4. Oops, sorry about that. Any outliers get represented separately along this middle line of the box. 18 is an outlier, so I'm going to put a cross at 18 to show that there's an outlier. We measured, we did the test, it is an outlier, and we're placing it there. The whiskers of the box plot, or the box and whisker plot, come out from the center of the box, and they represent the outside quartiles, but not the outliers. So the smallest data score is 1. So there at 1, you put a small bar in line with the middle of the box and the whisker out to it. The largest data point apart from the outlier is 7. So there will be a bar there at 7 and the line going out to it. So this very clearly illustrates the distance that your outlier is from the rest of your data. And apart from the outlier, each of these zones contains 25% of the data. So the lowest 25% is between 1 and 2. The next 25% of the data is between 2 and 4, and so on. So this is a box plot. You must draw the number line, mark any outliers with a cross. The box gets Q1, Q2, Q3, and the minimum and maximum apart from outliers form the whiskers. That's how you make a box plot. At times you would compare two sets of data on the same number line. In that case, you would draw your second box plot above the first, and you would label what those data sets were. So data set A and then data set B, for example. When you're looking at the skew of data, we didn't talk about the skew of data very much. Remember, if you've got data that's very clustered up one end, I'm just going to draw an imaginary thing there, and then tails off, the direction of your skew, this is positive, means this is positive skew. And it's interesting to look at what that would look like on a box and whisker plot, because you're looking for how your 25%, how your quarters of your data are allocated. And if you think about each of these is maybe a single data point, let's say that's 1, then I'm looking at 1, 2, 3, 4, 5. There's quite a lot of data here. There's not very much data here. So you'd see a box and whisker plot where there wasn't a very big range of where your data was here, but your data's very spread out just there. So this means a quarter of the data is very spread out just here. If we were seeing a negative skew, then we would see our data focused up on the positive side. This is a negative skew, very badly drawn, I'm sorry about that. And so we'd expect to see in our box and whisker plot our data spread out on the negative side. So if you're asked for positive and negative skew, think about what that box plot means. A large zone is more spread out for that quarter of data. A small zone, that quadrant of data, is quite compressed in.